Hi viewers, this is Sri Ramulu. So today's topic is intrinsic and extrinsic semiconductor. So first, intrinsic semiconductor. A semiconductor is an extremely pure form is known as intrinsic semiconductor. Okay. So pure form of semiconductor is called intrinsic. Pure form means no other things is added to it. That is a pure form. Only semiconductor means only one type of atom has to present. No other atom should not present. Okay. And next, or another definition, next second definition for this in the examination, which definition is easy for you, so write that definitions only. No objection on the writing definition, anyone. A semiconductor in which electrons and holes are solely created by the thermal excitation is called pure or intrinsic semiconductor. So because of temperature, thermal, if any holes, electrons and holes are created, equal number of electrons hole created, so that semiconductor what you call intrinsic semiconductor or pure semiconductor. So example for pure semiconductors are like germanium, silicon, which provides electron hole pairs are called intrinsic semiconductor. A not only electron and also hole has to produce. Next, the electron reaching the conduction band due to thermal excitation leave equal number of vacancies or holes in valency band, that is in intrinsic semiconductor number of free electrons is always equal to number of holes. So what he's saying, the electron reaching the conduction band. So actually electron where they go from VB to valency band to CB conduction band. Suppose the one electron is here. So because of thermal excitation means because of applying the heat energy temperature, then what happens, this electron may leave this valency band, enter into the conduction band, and its position becomes vacant. So vacant position is called hole. So like this, if there are the two electrons are jumped from valency band to conduction band, they leave two vacancies. So two vacancies are called two holes. Next, when external field is applied across an intrinsic semiconductor, the conduction through the semiconductor is by both free electrons and holes. So here when electric field is applied, what happens? Electron can move in single direction. So one electron is moving in this direction, opposite to it, hole will move. Okay, and a conduction through. So conduction means electricity or current is because of, in semiconductor is because of both. One is the free electrons and other one is because of holes. The free electron in the conduction band move towards positive terminal of the battery, while the holes in the valency band moves towards the negative terminal of the battery in the opposite direction. So free electrons are negatively charged particles. So electrons may present in the conduction band. So they move towards the positive terminal. Why it is negative? It attracts with the positive terminal. Moves towards the positive terminal of the battery. Next, hole is a positive. Okay, hole is a positive. It present in valency band and moves where towards the negative terminal of the battery. So positive can attack with the negative. So that is the positive terminal of the battery. So but if electron is moving in this direction, hole can move opposite to it. That is the last point. It may be noted that current in external wires is only due to the electrons as shown in figure. So generally if you take any like this, suppose it is connected to the battery. Okay, so suppose electrons are moving in this direction. Why electrons are negatively charged particle attract with the positive terminal. Okay, and then hole moves in this direction. Where to where? Hole can move from here to up to this end only. Beyond this end they cannot go. but outside of this substance what will flow, only electron motion will occurs. Okay, so electron can move through the wire like this, but holes cannot move, only hole can move inside this material only. As the holes reach the negative terminal B, the electron reaching there combine with the holes. Okay, now after reaching the negative terminal they combine with the, here see diagram is given. See, holes only within the substance only, but outside is see electrons only outside, right? Holes are thus destroyed, means when electron combined with the holes, then holes cannot be appeared. At the same time, loosely held electrons near the positive terminal A. So electrons are at the end A where end A is see here. So it is end A, end B. Attracted away from their atoms into the positive terminal. So where any electrons here, they attract towards this side. Now new holes are created which again drift towards the negative terminal. Suppose the electron is came here this side, then one new hole will create, then that moves towards positive terminal of the battery or B side. And see, this is the diagram of intrinsic semiconductor. So silicon is taken and outermost electron in the silicons are 4 electrons are there. So these 4 electrons are covalently bonded with the neighboring silicon. Okay, so it is a bond form, covalent bond this side and this side and this side, this side. So no any, see, only we have the silicon only. So except silicon, no other elements are there. So that is, it is a pure semiconductor. Next, extrinsic semiconductor. At a room temperature, intrinsic semiconductor has a little current capability. So at room temperature what happens, electron hole pairs will generate. So then small amount of current will flow. That is the capability of current capability. In order to use a semiconductor in electronic devices, its conduction property should be increased. So right, so if you want to use any semiconductor in electronic devices, then what we have to do, we have to increase their conduction property, we have to increase. The electrical conductivity of intrinsic semiconductor can be increased by adding some impurities in the process of crystallization. Suppose it is a substance, I am going to make it is a, I am going to prepare it is as a one crystal. Okay, so crystal means I should arrange the atoms in order. While arranging atom in order, so I am going to use I am going to add some other atoms in the middle like this. Then what happens, so it's a conduction property can changes easily. The added impurity is very small, of order of 1 atom per millions atom. Suppose there are the 1 millions of silicon atoms are there. 1 millions of silicon atom, we have to add other atom, only 1 atom. Okay, so in between the 1 million atom, only one other atom will present. That one other atom is called impurity atom. Right? Pure semiconductor, such a semiconductor is called extrinsic semiconductor. Okay, so for the pure form, if we add any other material and any other elements, that is becomes impure. Impure is called extrinsic, impure is called extrinsic. See, the diagram is also given. And see, as silicon, it is a pure form of semiconductor. To this one lead is added. So here also silicon, one boron is added like this. Okay, so that is why it is impure, it is impure. These impures are called extrinsic semiconductor, and depending upon the adding material, again this material is divided into two types, one is N type and another one is P type. So that is I will discuss now. Okay, the process of adding impurities to a pure semiconductor is known as doping. So the process of adding, suppose I see it is a pure form of semiconductor, to it lead is added. So this process, what you call, we call this process is doping process. The doping material is either pentavalent atom like phosphorus, antimony, etc. fifth group elements, or trivalent atoms like boron, aluminum, indium, or third group elements. Okay. So pentavalent impurities. How many types of impurities are there? Two types. One is a pentavalent, means five valence elements, and trivalent means three valence element or fifth group element, and third group elements are there as impurities. By adding pentavalent impurities to the pure semiconductor, n-type semiconductor will be formed. Okay. So in the process of doping, if you dope with the fifth group elements are called pentavalent, then n-type material will be formed. By adding trivalent impurities to the pure semiconductor, p-type semiconductor will be formed. So see here, p-type semiconductor is, so boron is trivalent element. So a trivalent element is added to pure form of semiconductor, that is which is prepared by the silicon, and it is converted into p-type. So n-type, p-type. So already I explained about the n-type and p-type. So see there clearly about how does the n-type and p-type forms, and what it gives and what it gives. So all those things are explained in the n-type, p-type semiconductor. Okay friends, thank you. Don't forget watching this video till the end.